This is 2013 FRQ number 1 on the calculator portion. So it says on a certain work day, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T, where T is measured in hours and T is between 0 to 8 hours. At the beginning of the workday, T equals 0, the plant had 500 tons of unprocessed gravel. So at T equals 0, we have 500 tons. During the hours of operation, between 0 to 8 hours, the plant processes gravel at a constant rate of 100 tons per hour. First part says, find G prime of 5. Use correct units. Interpret your answer in the context of the problem. So first, let's find G prime. Right? So G is the rate at which the gravel arrives at the processing plant. So part A, G prime of T. All right, so G prime is 90 is a constant, 45. Cosine is negative sine of T squared over 18. Chain rule, now T squared over 18 has a derivative of 1 over 18 times 2T. All right, so then let's clean this up. This is very messy, I apologize. So we have 2 times 45, 90 over 18, that's negative 5. Negative 5T sine of T squared over 18. Okay, and now let's plug in 5 because it says G prime of 5. So G prime of 5 is negative 25 sine of 25 over 18. Plug this into the calculator. Make sure you're on radian and not degrees. You should get negative 24.588. What this means is that this is the rate at which the rate of the gravel is coming in. So the rate is decreasing because it is negative. So it is decreasing at a rate of negative 24.588 tons per hour. Per hour. So it's the acceleration of the rate, essentially. So this is the rate of gravel arriving is decreasing because it's negative at 24.588 tons per hour squared at T equals 5 hours. Okay, all right, that's it for part A. Okay, part B then says, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So the amount that came in, so we can ignore the 500 that we started with. How much came in, right, at the rate this came in between 0 to 8 hours. So part B is a simple integration, 0 to 8 of G of T dt, 0 to 8, 90 plus 45 cosine of T squared over 18 dt. This is all calculator. So let me take out my calculator. All right. Then let's go math 9, 90 plus 45 cosine T squared over 18. All right, I think that closes my parentheses. X comma 0 comma 8. Okay, if you don't close your parentheses, your calculator will complain. So it's really not that big of a deal sometimes. All right, so 825.551. So 825.551 tons. Okay, all right. What does part C want? Part C says, is the amount of unprocessed gravel at the plant increasing or decreasing at time T equals 5 hours? Show the work that leads to your answer. Okay, well then we gotta compare the amount of unprocessed coming in, the rate at which it comes in, and the rate at which you are processing it, right? So we're looking for G of 5, right? We simply plug 5 in here. So 90 plus 45 cosine of 25 over 18. So 90 plus 45 cosine 25 over 18. And we get 98.141, right? So it is coming in, right? It is arriving at a rate of 98.141 tons per hour, but it is processing 100 tons per hour. So coming in is less than getting processed. So the amount is decreasing, right? Because coming in and you're processing more than is coming in. So the arrival is less than the process. Therefore, the amount is decreasing at t equals 5 hours. Okay. Last but not least, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So the amount, you want to find the amount of gravel, right? So first of all, you need to create an equation, a formula for the amount. We started with the amount of gravel. You start with 500, that's how we started, right? Plus however many hours that you have the gravel coming in, so the arrival, G of t, so 90 plus 45 cosine t squared over 18. But then you are processing at the rate of 100 tons per hour, so minus 100 times whatever hour it is, right? So that's your formula for the amount of gravel. Then you want to find the maximum of this, which means you can find the derivative of this is set equal to 0. So your plan of action is a prime is set equal to 0, right? So if we take a prime, what do we get? 500 is a constant, it goes away. The derivative of the integral is just simply the equation. 90 plus 45 cosine of t squared over 18 minus 100t minus 100. So this equals 0. 0 equals 90 plus 45 cosine of t squared over 18 minus 100. You move the 100 over, is simply when 90 is equal to 90 plus 45 cosine of t squared over 18. All right, so you plug this in the calculator or solve for it. It's up to you, but what will be easier? I will solve for it. So subtract 90, you get 10 equals 45 cosine t squared over 18 divided by 45. So 2 over 9 equals cosine of t squared over 18. And then cosine inverse of 2 over 9 equals t squared over 18. 18 cosine inverse of 2 over 9 equals t squared. T equals, well, there's no plus or minus because there's no negative time, so it's just root 18 cosine inverse of 2 over 9. Okay, that's a little bit easier to plug in. So root 18, oops, not cosine, cosine inverse of 2 over 9, and that will give me 4.92348. 4.92348. All right. So is this truly the maximum? We don't know because this thing has an endpoint. This equation, this whole story has an endpoint of 0 and 8. It starts at 0 hours, ends at 8 hours. So what you need to do is you need to plug them in and see which one of these gives you the maximum. So you got to plug in A of 0, and we already know that because initially there's 500. Done. All right. A of this amount 4.92348, and the A of 8 at the end of 8 hours. Okay, so let's see. First one will give me, I am going to find the integral first. So math 9, integral of 90 plus 45 cosine of t squared over 18, parentheses, comma, x, comma, 0, comma, 4.92348. So this is how much gravel came in, plus the 500 minus 100 at the rate of, also at the hour of 4.92348. So, oops, what did I do? Oh, let's try this again. I plugged in the wrong thing. So second, enter. So answer plus what did I miss? I miss and a parentheses. All right, so 500 minus 100 times 4.92348. That gives me an amount of 635.376, which is great. It's already more than my initial. All right. So last but not least, check the 8. So what is the 8? So at 8 hours, at the integral, math 9, of 90 plus 45 cosine t squared over 18, parentheses, comma, x, comma, 0, comma, 8. So how much gravel came in at 8 hours? So that's how much gravel came in at the end of 8 hours, which we already have from part B too. And then at the 500 I started with, minus at 8 hours, I need to multiply by the 100 tons per hour. So I have 525.551. So as you can see, this is truly a maximum because it has the most of all of them. So max, let's see, what is the maximum amount? So max amount of 635.376 tons and at 4.923 hours. Okay, and that's it.